Matter. You breathe it, eat it and bleed it. Everything is made out of matter. It can be divided into pure substances and mixtures. There are two types of substances, elements consisting only of one type of atom, which might or might not create molecules together. Compounds, on the other hand, need two or more different types of atoms combined with chemical bonds. Finding pure substances isn't that easy though. All the materials we encounter in our daily lives are mixtures. Even the 24-karat gold can have up to 0.05% something other than gold. So there can be one other atom amidst about 2000 gold atoms, and that makes it a mixture. The purest material in our lives is the silicon inside electronics, which can have at most one non-silicon particle for every billion silicon atoms. Which means that if all the people on Earth were atoms in electronic-grade silicon, only 7 of them would be something other than silicon. And in principle, the 7 of them make it a mixture. So, let's get to know mixtures a bit better today on Kantomega. There are two types of mixtures. The homogeneous solutions and heterogeneous suspensions. Suspensions can be separated using filtration, while solutions can't. And that's because the particles in solutions are only the size of single molecules. Solutions can be divided by the solvent to liquid and solid solutions. Amalgams, which are alloys of mercury and other metals, are solid solutions. Gas mixtures aren't generally classified as solutions. Note that the whole solution always takes the phase of the solvent, which means that if you dissolve, say, sugar into water, the particles won't stay as a solid, but they will act like a liquid. The same doesn't apply to heterogeneous mixtures, where both of the materials will stay in their original form. Take the mixture of sand and water for example. The basic rule is that if you can see the particles in a mixture, it's heterogeneous. There is a limit to how much of a substance can be dissolved homogeneously. When a solution reaches this point, it's said to be saturated. At room temperature, water can dissolve over twice its mass sugar. If you keep adding the solute after this point, it will just stay in its original form and mix in heterogeneously. What is shaving cream? I can't see any particles, but there's a huge ton of air bubbles in there which, I'm pretty sure, aren't at the scale of molecules. Is it heterogeneous or homogeneous? Well, yeah, it's a colloid. There are three types of mixtures: the homogeneous solutions, heterogeneous suspensions, and colloids. Colloids can be categorized either as homogeneous or heterogeneous. There are several types of colloids: foams consisting of a liquid and a gas, emulsions mixing two liquids that don't dissolve, and gels combining a solid with a liquid. Colloids are sometimes called emulsions, but as emulsion is just one type of colloid, that's completely wrong. Let's take a few examples of colloids. Lotions. They are basically a mixture of oil droplets dispersed in water, so it's an emulsion. Jelly. It's made using gelatin, which is basically a solid. The bonds in a material break up when heated and it will get mixed in water. As the water cools, the gelatin tries to form the same bonds again, trapping small water droplets in solid structure. This makes jelly a gel. But how about clouds? They consist of small water droplets suspended in air. We've already learned that foams are mixtures of liquid and gas, so are clouds foam? Well, no. This comes down to the continuous phase and dispersed phase. All colloids have these. The continuous phase or dispersion medium forms the main structure of the colloid. The particles of the dispersed phase create little bubbles or clusters inside the continuous phase, while the particles of the continuous phase are always touching each other. So what are clouds exactly? They are a mixture of gas and liquid, like a foam, but the continuous and dispersed phases have switched places. In a cloud, air creates the structure of the colloid, while water is dispersed within as droplets. Clouds are actually an aerosol. Here are all the other colloids, even the less common ones. Note that two gases can't create a colloid, because gas molecules are moving so quickly they cannot trap other gas molecules, so they will just create a homogeneous mixture.